Okay, so this is a equation, or this is the problem set that says manipulating formulas. And what you need to be able to do, Common Core calls for you to be able to take an equation or a formula and then manipulate it or rewrite it, maybe to solve for a different letter in the formula. So in this case, this is just slope-intercept form of a linear equation. So in other words, it is an xy equation, right? An equation with an x and a y variable in them. And it is solved for y. So we notice that we have 3x over 4, which is the same thing as saying 3/4 x. So this is a slope-intercept. This will be the slope. It is a rise of 3, a run of 4. So that's the slope triangle there, 3/4. And then 9 is where the intercept is, okay? And it tells us that when that has a y-intercept of 0, 9. What that means is that the intercept, when x is 0, it's crossing the y-axis at the number 9. And you can see that because if you put 0 here, 3 times 0 would be 0. 0 divided by 4 is 0. 0 plus 9 is 9. So when x is 0, y is going to be 9. I usually just kind of cover that up. Okay, I just cover it up and say there is 9 because this is going to turn into nothing when I put x as 0. Now it says rearrange the equation to express x in terms of y. Now we just talked about solving in terms of one other variable in it. And it says assume that x is positive. So we want to solve for x now. So we're just going to do everything like we, think we normally would. 3x over 4 plus 9. If we were solving for x and we don't want to even think that that's a y, we would just, reverse our equation. We go in opposite order and we would just start picking this stuff off here. So what's the opposite of adding 9? We would subtract 9. So we take away 9. So that gives me y minus 9 equals 3x over 4. And then I would multiply by 4 to get that go away. And when I multiply this, I have to multiply this whole side by 4 and distribute it in. So I get 4y minus 36 equals 3x, right? And then I would divide this and this by 3, and I get x equals 4/3 y minus 36 divided by 3 is 12. Now you could use your GeoGebra or your GeoGebra or your TI Inspire CAS calculator to solve this, but we see what we have here is it looks just like slope-intercept form, except the y and the x have changed places. And in this case, we have a slope that is the inverse of the original slope. Instead of 3/4 x, it's 4/3 y. And that makes sense because if we change the axis positions, it would have a rise of x. It would go up the x-axis 4 and over the y-axis 3, just like before it went over the x-axis 4 and up the y-axis 3. So the slopes are inverted there. And then the only other thing that we're asked to figure out what the intercept would be. Well, if y was a big fat 0, what would the x-intercept be? It would be negative 12, right? So I could just say, if this were to go away, right, if this was a just big 0 here, because this is a factor, and if one of the, this is a product, and if one of the factors was 0, then you would have, let's see if I can undo that, get rid of some of those scribbles. If this became a big 0, one of the factors, then this whole product would turn into 0. So, my answer here is going to be that x is going to be negative 12. Let's see if I can draw here. Negative 12 whenever y is 0. If I put 0 in for y. And then, of course, my equation is going to be over here written as x equals 4/3 y minus 12. So let's put that in here. Sorry. There we go. So this is 4/3 y minus 12. And then when I'm going to get a negative 12 whenever y is 0. And there we have it. Let's try one more of these together. Here we go. I'll get another fresh page here. And we will copy that back here so I can write on it real nice. Here we go. Again, we're doing manipulating formulas. So we have some formula here. In economics, unit labor cost is calculated using the formula. All right, ULC, which is ULC stands for the unit labor cost, and O is the output per worker, and W is their compensation. So in other words, basically this is how many units are produced, right? That's how many units are produced by a worker. So this is their production, right, of units, okay? And this is their cost. So if we want to find out what the unit labor cost is, we take our total production in units and we divide it by our costs. That kind of makes sense. Now it says rearrange the formula to solve for the hourly compensation per worker. Well, that means solve for W. So that's not too bad. I have ULC is equal to O over W. So I would just multiply by W. Boom, boom. And that means I have to multiply this side by W. And now I would see that I have W times ULC equals O. And to solve this, I would divide by ULC on both sides. ULC, and this will cancel. And I have W by itself is equal to O over ULC. So that would be my answer. Worker hourly compensation per worker can be calculated by taking the output or the production, and that's per hour, and dividing it by the unit labor cost. Okay. So we have output over unit labor cost. Output over unit labor cost. There it is right there. And these are pretty fast to do actually, so I'll try another one. In accounting, receivables conversion period is a measure of how efficiently a company collects the money owed by customers. All right, receivables conversion period. Okay, so this is what is a receivable? That's a lot of words, man. Receivables conversion period. What it is, it's a measure of how effectively a company collects money owed by customers. So if you owe the company money, that company is tracking how good they are at getting paid back. And this is the formula they use, 365. So RC is the receivable conversion period. So it's a measure of time. It's equal to 365. Guess what? That's the days in a year, right? So maybe this is why it is converted to time, right? 365 times 1/2 BR. So 1/2 times the sum of our beginning receivables and our end receivables. So we take those together, the beginning and the end receivables. We divide them in half, right? Or we multiply by half, right? And then we divide it by the net credit sales. All right? And this will tell us, you know, how much did we have in the beginning of the period, how much do we have in the end of the period that was owed to us, and we divide that in half so that we get an average amount owed to us, and then we put that over the amount of sales we extended on credit. So that's what it says. Well, basically, it's really not that hard. All they want us to do is they want us to solve for NCS. So this one, another really, you know, a lot scarier looking than it really is. Hold on, let me get another page here. Really, you can just forget about the economics of it unless you're interested in that stuff. And guess what? I like it, so maybe you will too. Who knows? If you can kind of work your way through it and think about it, maybe Mrs. McManus can help you figure this stuff out. But here we go. What we're going to do is we're just looking at this equation. We're saying, let's get rid of, we want to solve for NCS, which means we need to get it out of the denominator. So if we multiply this side by NCS and this side by NCS, then I can cancel this and that. Now I have NCS times RC is equal to all that. Well, what am I going to do? I want to get rid of RC, so I'll divide by RC so I can cancel it. But that means I better divide this side, the whole thing, by RC. So my answer is NCS, net credit sales, is equal to 365 times 1/2 BR plus ER, beginning receivables and ending receivables, all of that divided by RC, which is our receivables conversion period. So here we have 365, where's the 1/2? Uh-oh. Aha, well, guess what? No. Hold on a minute now. Yeah. When I take all of this and I multiply it by 1/2, I'm really moving the 2 down into the denominator, aren't I? Right? I mean, this whole product is taking half of this, which means I could just write it as divided by 2. So another way to write this is like this. 365 BR plus ER. And this got to be grouped together because it is a factor in a product. The other factor was times 1/2. Well, times 1/2 is the same thing as divided by 2. So I'm going to just show it as divided by 2. And then, of course, it's also being divided by RC. Well, and that gives me 365 BR and ER divided by 2RC. So we'll go with that guy right there. Okay, so that's how those are done. Get manipulating formulas done now, okay? Thank you.